Last class we talked about add with carry and um, DAA, decimal adjust accumulator, in the case of BCD addition. So next is subtract. So here they are talking about two types of subtract. One is SUB and the other is subtract with borrow, SUBB. So in the case of 8051, which we are dealing with, you have only SUBB or the subtract with borrow. You don't have SUB. Okay, so you can only subtract with borrow, and here the borrow is considered, the borrow is taken as the carry. Okay, so if carry flag is set to 1, that will be taken as a subtract with borrow, and carry flag is 0 means subtract with borrow is taken as 0. So subtract a, SUBB a means comma source means the accumulator gets the value accumulator minus the source value. The register, then the register value contents of the register minus the carry. Okay, so here you always have this carry. So A minus source minus carry is the result in the accumulator. So the carry can be either 0 or 1 depending on whether you have a borrow or not. So if you want to do subtract with no borrow or SUB like in other assembly language programs, you'll have to make Cy equal to 0. So Cy equal to 0, you clear the carry prior to the execution of that particular instruction. Then you can make Cy equal to 0, so that this will be equivalent to doing subtract without any borrow. So since you have only this kind of an instruction SUB, and if you want to do subtract without borrow, then just clear the carry prior to the execution of the instruction. So we are taking two cases where subtract when carry is equal to 0 and subtract when carry is equal to 1. So when subtraction is done with carry equal to 0, then these are the steps. That is, take the 2's complement of the subtrahend. Subtrahend is the second number. A minus B means B is the subtrahend or the source operand, and add this to the minuend. Minuend is the first number. So SUBB A comma source means A is the minuend, the content of A is the minuend, and content of the source is the subtrahend. Okay, so you are taking that is if you are doing 3 minus 2, you'll be taking what, 3 plus the 2's complement of minus 2. So the same thing we are doing here. You are taking the 2's complement of the subtrahend and adding it to the minuend. Okay, and an additional step is that you have to invert the carry, whatever you're getting after this first two steps. At the end of the second step, whatever carry you're getting, the final carry will be the invert or the complement of the carry. Okay, so here we are taking an example. We are going to subtract 4c and 6c, 4c minus 6c, 6c from 4c. Okay, so this is what we are going to do, and for that first you will move 4c to accumulator because it's always A minus the source. Then move 6c, subtract 6c from 4c by using the instruction SUBB A comma 6CH. So that 4c, which is an accumulator, minus 6c, which is the source, immediate addressing, and the result will be stored in the accumulator. So here we are checking. See, this is 4C, okay, and 6E. So this is 6E, just 6E, not the 2's complement. This is the binary equivalent of 6E, not minus 6E, just plus 6E. Then you are taking the 2's complement, that is, take the 1's complement and then add 1 to this subtrahend, so that you get this, and you add this minuend, the content of accumulator, which is 4C, plus the 2's complement of minus 6C. So you add this. So you know that 4C minus 6C, the result will be a negative number. So how does the system, or how does the microcontroller know that it's a negative number? Here, see, the carry is 0. Carry is 0. So what was the third step? Invert the carry. So you'll be inverting the carry. So now the carry is equal to 1. So if carry is equal to 1 after inverting the carry, after the third step, if carry is equal to 1, then the result is negative. And the destination has the 2's complement of the result. That is, this has the 2's complement of the result. And if Cy is equal to 0, carry is equal to 0, then the result is taken as positive. Okay. So this we have to do using this program. So A has the value 4C. Subtract A comma 6C means 4C minus 6C. So jump if no carry to next. So jump if no carry means you're going to store the result in R1. And if there is a carry, then complement A, that is, take the 1's complement, and increment A, that is, you are taking the 2's complement. Okay, so no carry means you're going to move it to R1. If there is a carry, then you'll take the 2's complement. So that is when carry is equal to 0. If carry is equal to 1, this is normally used in cases where the numbers are big. Okay, multi-byte numbers. If you are subtracting multi-byte numbers, then you will be making use of carry equal to 1. So here the question is 2762 minus 1296, both in hex. So the higher order bytes are 27 and 12, and lower order bytes are 62 and 96. So you'll be first subtracting 62 minus 96. Then you will be subtracting 27 minus 12. So 62 minus 96, you will be moving 62 to A, SUBB comma 96 means 96, 62 minus 96, and the result will be stored in A. So if you do that, you'll get the answer as CC. And this value, that is CC, that is the subtraction, the difference of the lower bytes, I'm moving to a register R7. Why? Because I need the accumulator again to subtract the higher order bytes. Okay, so whatever is stored in accumulator, I'm just moving it to a register. Here I have used R7. Then again accumulator is loaded with the higher order byte, subtracted with 12, that is 27 minus 12, and the result I'm moving to R6. So in this case, when you're using multi-byte, the carry should be equal to 1. The carry should be made equal to 1, and then only subtract. And here when you subtract, so you'll have the lower order byte result in R7 and the higher order byte result in R6. Here also carry is equal to 1. Okay. Here also, okay, this carry, okay, 62 minus 96, when you do, you get a carry equal to 1, and that carry comes here because carry is set to 1. So for that, that carry comes here, and when you do the higher order subtraction, this carry, since it's set, then that is subtracted from here. In this case, first carry is equal to 0 only. Okay, 62 minus 96 minus carry 0. The result will be CCH with a carry 1. This carry 1, where is it used? In the higher order byte subtraction. And when you do that, the result you get is carry equal to 0. You can do that and check if the answer is correct. Next is multiplication and division. So we dealt with addition, BCD addition, and subtraction. Next is multiplication and division. So multiplication, you know that in the case of multiplication, the result will be a bigger number. So MULAB is A into B. What happens is A into B, and the 16-bit result will be stored in B and A. The higher order byte in B and the lower order byte in A. So suppose you want to multiply 26 and 65. I'll just move these values to A and B and multiply AB, so that the answer is E99. Of that, 99 is the lower order byte and 0E is the higher order byte. 0E will be stored in B and 99 will be stored in A. This is the format. Yes. Next is division. DIVAB. That will be divide A by B or A divided by B. So if you want to divide a number from another number, you'll be loading it like this. Here there is a mistake. This is not MUL. This is DIV. Okay, this is a mistake. So here what happens is 95 divided by 10. So what is the answer? You have 9 as the quotient and 5 as the remainder, and the remainder will be in B and quotient will be in A. And if suppose B, A divided B by B, when you do that, if B becomes equal to 0 at any time, then the overflow flag will be set to 1. That will show that there is an error, because you cannot divide a number with 0. So overflow flag will be set if during the course of division the denominator becomes equal to 0. So in 8051, how do you represent a negative number? It is just like the 2's complement form. So minus 34H. So that is in hex. You convert it to binary first, the positive number, 34H in binary. Then take the 1's complement and then add 1 to it to get the 2's complement. If the result of an operation on a signed number is too large, okay, if the result is too large, then an overflow will be set. Overflow flag will be set to 1, showing that the result is too large. So here suppose we are going to add two numbers, 96 and 70. See, when you add 96 and 70, the actual result should be 166. Okay, so 96 you know is an 8-bit number and 70 is also an 8-bit number. Sorry, 96 and 70 in decimal. Okay, 96, yeah. 96 and 70 in decimal. This is decimal, not hex. Okay, so this is 96 and this is 70. If you convert these decimal numbers to binary, and this is the hex of that. Okay, and suppose you are going to add these two numbers, and if you add these two numbers, what happens is 96 and 70 here, what happens is since you are writing 166, it's a larger number which cannot be accommodated using the same number of bits as in 96 and 70, which is the 8 bits. You need an additional bit to represent 166. So in that case, overflow will occur. Okay, so here what is said is this is A and this is R1, that is 60 and 46. So if you add these two, there will be minus 90, which is invalid because the answer is not minus 90. 60 plus 46 is 0 plus 6 is 6. 6 plus 4 is A. So that is A6. A6 is 1010 and 0110. So since the MSB bit is 1, that is treated as a negative number, and so this will be an invalid number. So in such cases, the overflow flag will be set to 1. So you need more number of bytes to or bits to represent this particular number. You cannot do this using so many bits. So there are two cases during which the overflow flag is set. One is when there is a carry from D6 to D7. Okay, D6 to D7. This is D6 to D7. So 1 plus 1 is 0, carry 1. So if there is a carry from D6 to D7, but no carry out of D7, that is final carry out is 0. So D6 to D7 there is a carry out, but from D7 there is no carry out, then an overflow occurs. That is one case. Second case is if there is a carry from D7, that is Cy is equal to 1, but no carry from D6 to D7. First case is if there is a carry out from D6 to D7 but no final carry out. And second case is when there is a carry out from D7 but no carry from D6 to D7. In both these cases, the overflow flag will be set to 1. So these are all in the case of signed numbers. Okay. So here we are doing minus 128 plus minus 2. So the answer should be minus 130. So we are just moving the values to accumulator and a register. So minus 128 and minus 2. This is the 2's complement form. Okay. So this is 80 and this is FE. And if you add these two, then your answer will be 70. Okay. 0, 1, 1, 1. So 1, 1, 1, 0. Here will be 1, 1, 1, 0. So this is 7 and this is 8. So you know that 80 plus FE cannot be less than 80 or FE. 70 is less than those. Okay. So 70 is 126 which is less than 128 and 2. So that is invalid and an overflow flag will be set. Why? Because here there is a carry out but no carry from D6 to D7. So this is another example. Minus 2 plus minus 5. The answer should be minus 7. So minus 2 and minus 5 is written in 2's complement form. The result is F9. So here it is FE plus FB. So the answer will not be less than that. Answer which we got is F9. So the overflow flag should be set. So here you can see that, FE and FB. Okay. So here in this case, this is 1, this is 0, 1, 1 plus 1, 0. This is 1, the 1, carry 1, 1. Okay. So this is F9. Okay. So F9 means if you take the, this is negative number. So if you take the 2's complement, this will be 0, 0, 0, 0, 0, 1, 1, 0 plus 1. So that is 7. So it is minus 7. So the answer is correct. And also if you check those two conditions, you can see that D6 to D7 there is a carry. But here we have a carry out from D7 also. So two types of carries are there. So the answer is correct and overflow flag is not set to 0, not set to 1. cases when you are adding two numbers 7 and 18. So this is 7, these are both positive numbers. So this is 7 and this is 16 plus 2, 18. These are in decimal, so convert it to binary. So if you add this 1, 0 carry 1, 0 carry 1, 1, 1. Here you don't have a carry out from D6 to D7 and there is no carry from D7 also. So the overflow flag is 0 and the answer is correct. So overflow flag is equal to 1 and the answer is incorrect in the case of signed numbers only if there is a carry from D6 to D7 but no carry out from D7, or if there is a carry out from D7 but no carry from D6 to D7. So these are the two cases wherein you have an overflow flag set. Now this we have already told. To find the 2's complement of a particular number, what do? You can complement that number and then add 1. So you can move that number to the accumulator, you can complement the contents of accumulator and then add 1 to the accumulator. So you can just try out these in EdSim and check whether you're getting the answers. You can also do it using pen and paper and check whether you're getting these answers. You can try out these problems.